Hello everybody, today we're going to look at the motion of a cart moving down a track. Basically, I'm going to push this cart down the track, and what's happening is there's a little signal bouncing off of here to this little reader, and it's basically going to measure the distance between the cart and the starting point, okay? And then we'll produce a graph basically with the distance on the y-axis and the time on the x-axis, okay? So let's run a trial and see what happens. And there's our cart moving down the track. Okay, and we can now get a nice little graph here, okay? You'll notice the very beginning of the graph is actually showing a flat line. What that's actually doing is showing just that time at the very beginning of the trial where the cart was basically sitting here. Before I hit the button here, it took about a second for me to get up here and move the cart. So right in that little flat spot, that's not moving. The more important stuff for our purpose is right here. And you see a nice, perfectly straight line with a nice constant slope, showing that this cart is moving basically at the same rate. It's basically moving a constant distance over every time interval. Okay, so when things are moving at a constant speed, we get a nice, flat, positive slope, okay? In this case, it's moving away from the device it's measuring. The next trial I'm going to do, I'm actually going to move it toward the device, okay? And your question now is going to be to explain how you think this graph will change. Okay, what will be different about that graph when it's moving toward as opposed to away?